All right, so welcome everyone to today's lesson. So for the first half of this lesson, we will be going through this selective test over here. So this was the one for 2022. And for the second half of the lesson, after we have like around a 5-minute break in the middle, we'll be going through the questions in the other booklet, right? So for this test in particular, I will mainly be going through the questions myself. But if you do have anything to add, you can feel free to raise your hand. If you maybe have like a different method or something else, right? So before I jump straight into the questions, let's talk a little bit about the time management for this test, right? If you look at this front page over here, we can see it's going to be 40 minutes long. And during this 40 minutes, we're going to have to do 35 questions. So if you sort of think about like what question you should be up to given like the time, if you do every question in around a minute, then you're going to have 5 minutes in the end to spare, right? And that's sort of what you should be aiming for, roughly. So if you're able to do the questions a little faster than that, that's great. But if you find that you're lagging behind, so for example, maybe 20 minutes in, you're only up to question like 15, maybe that's a sign to step up your pace, right? So for a lot of these questions, we will try and aim to do each one of them in around about a minute, but obviously some questions are going to be harder than others. So let's go ahead and jump into the first question of this test. So 3 packages are weighted together. The total mass is shown on the scale. Package 1 has a mass of 850 grams, package 2, 225 grams, and we want to find the mass of package 3. This one will be pretty straightforward. We can see this pointer over here going halfway between 2 to 3 kilograms. So the total mass is going to be 2,500 grams, right? I'll just convert it into grams just so that we're dealing with the same measurement. And then in terms of package 1 and package 2, how much will they weigh? It's going to be 850 and 225 grams each. If we go ahead and add them up, we're going to get 5, 7, 1, and 0. So the third package is just going to be the difference between these two, and that's going to be 1,425 grams. So the answer is going to be C. Pretty straightforward. So moving on to question number 2. At a garden shop, Claire is packing plants into boxes. Each box holds 6 plants. She has 149 plants and she wants to fill 27 boxes. And we want to find how many more plants does she need. So each box is 6 plants. There are 27 boxes in total. So how many plants do we need to fill, right? Just want to multiply these numbers together. We have 162. But then we have only filled in 100. We only have 149. So how many more do we need? Just finding this difference is just going to be 13, right? So this one is going to be D. So you'll notice for a lot of the questions, I'll be underlining the more important parts of the question. A lot of the numbers that is given, because like we don't really need to know that, oh, it's a garden shop or we're packing plants into boxes. All we care about is that each box is 6 plants, be 149 plants, 27 boxes, right? So moving along to question 3. The diagram below follows these rules. Multiply the number in the square by 4, multiply the number in the triangle by 3, and find the difference between these two results and write it in the circle. And we have a bit of this diagram filled up. And we're also given that the number in the square is greater than 1. So what is this number in the square? So if you sort of backtrack from this 14 over here, we have the difference between this number times 4 and this number times 3, which is 6, is going to be 14. So we want a number when we have the difference with 6 will give us 14. And that number is just going to be 20, right? 20 minus 6 is 14. And now we work backwards again. What number multiplied by 4 gives us 20? This is just going to be 5, so it will be C. And once you get this result, it's always good to check your answer by substituting back in. So 5 times 4, yep, it's 20. 2 times 3, 6. And then that difference is 14, right? So once you get pretty good at doing these tests and doing these questions, it just becomes a matter of trying to make as little silly mistakes as possible. right? So these are questions you are going to be able to solve. So it's just a matter of trying to do them very carefully. And for this question also, you don't really even need to work backwards to get 20 and to 5 anyways, because we're given 5 options. We know one of these options is going to be correct. So if you're struggling a bit more with this question, you can always just guess and check, right? Is the answer 2? No, it's not. Is the answer 4? No, it's not. And then you see that, oh, if I substitute 5 in, everything's going to work out. So this will take maybe a little more time, but like we have 40 minutes for this test, which should be plenty to do everything. Right, moving along to question 4. So Rana, Penny, and Joshua share a pizza. Rana eats 2/10 of the pizza, Penny eats 4/10 of the pizza, and Joshua eats 2/5 of the pizza. So I'll just go ahead and quickly convert this to 4 out of 10, just because easier to deal with the same denominator, right? And we want to find which of these statements are correct. So this is going to be a very common question type where we're given 3 statements and we want to find which of these are going to be correct. So we just have to go through each one of them. Statement 1, 2, and 3. First of all, do they eat the whole pizza? Well, 4/10, 4/10, 2/10. If we add them all up, we get 10 out of 10, right? So that's going to be correct. Joshua eats the least pizza. Well, Rana is going to eat the least pizza, right? That's 2/10. So statement 2 is not correct. And Penny eats twice as much pizza as Joshua. Again, this is not true. They eat the same amount. This trick question is probably trying to trick you up by if you just rush too quick to say, oh, 4 is twice as big as 2, but only statement 1 is going to be correct. So this one will be A. All right, moving along to question 5. So which of the following calculations show how to work out the number of seconds in 24 days? So just from looking at the options given, you sort of tell we're going to have to convert it into maybe hours and minutes and seconds a step at a time. So let's go ahead and do that. So we're starting off with 24 days. And then now let's go ahead and convert this to hours. There are 24 hours in a day. So how many hours are there in 24 days? 24 times 24, right? And then now we want to convert it to minutes, so we can convert it to seconds. So 60 minutes in an hour, we have 24 by 24 by 60 minutes. And then finally, to convert into seconds, multiply by 60 one more time. We get 24 times 24 times 60 times 60, which is going to give us the option E, right? So I've written out all of the lines of working out, and the only reason I did this is because if we're able to do it one step at a time, it's going to reduce the chance we make a silly mistake, right? If you rush this question too quickly, maybe you missed out on a 24, maybe you missed out on the 60, and you really want to be getting every question you can, right? So yes, if you you can do this question without writing a lot of the working out, but if you do so, just make sure you're going to be extra careful, right? Check your answer is going to be correct in the end. Right, question number 6. So we have that there are a total of 160 children in 6 classes in a school. The column graph shows the number of children in classes 1 through to 5. And we're not given the column for 6. And we know that there are 30 children in class 3. So I'll just write 30 over here. Might be a little bit hard to see, but just from looking at this diagram, we can see that there are like, this 30 is made up of these 3 sections over here. And looking at each of these sections, it's made up of 1, 2, 3, 4, 5. So we sort of know that each of these little increments is going to be 2, right? So to find the number of children in class 6, we just want to find 160 minus all of the children in every other class, right? So let's go ahead and do that. So class 1 looks like there's going to be 20. Class 2 looks like there's going to be 28. Class 4 looks like there is 26. Finally, class 5, 24. And let's go ahead and add these numbers up. So how I like to add these up, I like to count the tens first and then count the units after. So what I mean by that, I'll see, oh, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there are 11 tens, that's 110. And then the 6 and the 4, moving on to the units, they add up to 10. and this 8 is just going to be 8 itself. So very quickly, I can get that the sum is going to be 128, and then if there's going to be 160 total, then what's 160 minus 128? Gives us 32, right? Which is C. So at any point, if you want me to go back to a question because you missed the answer, you can feel free to message me in the chat, right? But other than that, let's go ahead and move on to question 7. So the total mass of the objects on the left side of the balancing scales is the same as the total mass on the right. And then we have triangles are equal, squares are equal. And if the triangle is 6 grams, what's the mass of a square? So for this question over here, we want to try and simplify this weight as much as possible. And we can do that by pretty much cancelling out some of the objects, right? If we take away a triangle on the left-hand side and we take a triangle from the right-hand side, it's still going to balance, right? If we take a square from the left-hand side and we take a square from the right-hand side, it's still going to balance. And then we sort of have this relationship over here. We have 2 squares is equal to 3 triangles. If 3 triangles is going to be 18 grams, then each square is going to be 9, right? And that answer will be D. All right, moving along to question 8. So the table shows the exact times by 5 racing drivers to complete 1 lap of a circuit, and we want to find the fastest 3 drivers, starting with the fastest. So this question might be a little bit of a trick question because the times, if we want a faster driver, we want a smaller time, right? They can complete the race in a short amount of time. So we just want to find the 3 smallest times. So looking at all of these options, I can sort of see that, oh, Adam is going to have the fastest time. So Adam will be my very first person. I'll cross out the options A, B, and C. And then rather than finding the second fastest time, I can sort of look at my options. I know it's going to be D or E. And looking at these 2 options, I know that Smith has to be the second fastest, just because her name here is in the answer, right? And I know that one of these is correct. So all I need to do is pretty much compare between Evans and Batra. So which of these is going to be faster? Who's going to be faster? Looks like Batra's going to be faster by a little bit, so the answer is going to be E, right? So you can always use these answers to your advantage. And this is something that is very, very useful when doing the selective test, because with a multiple choice answer, if we know one of them is correct, then we can always use some sort of a process of elimination. Right, question number 9. A boy standing at P is facing east. So east is going to be that way, and he turns clockwise, so clockwise being this way, to face a house which is at point H. So we want to find his angle of turn. So what is this angle over here, right? That's pretty much what the question is asking. So if you try and split this angle up a little bit, yeah, it's going to be 210, right? So we're doing full 180 to face the other side. And then we're rotating another 30 degrees, right? We have this 30 plus 60 is 90. So 180 plus 30 is equal to 210. So, yeah. Right, moving along for question 10. So this one seems like a bit more of a lengthy one. So Alex had $76. He spent some of it in a shop. He then gave half of what he had left to Charlie. And then Charlie spent a quarter of what Alex gave him on lunch. And then Charlie spent $9 on lunch. So this is another question which you can solve by working backwards. And it's probably going to be my preferred way of solving this also. So let's go ahead and try and relate all of these different sentences together. So Charlie spent a quarter of what Alex gave him on lunch, and Charlie also spent $9. So that means we know that this $9 is a quarter, right? So how much was Charlie given? $36, right? If $9 is a quarter, then the whole thing is going to be $36. And then Alex had given half of what he had left to Charlie. So this $36 over here is going to be half of what Alex had left. So what did Alex have left then? $72, right? Just double this amount. So how much did Alex spend in the shop? He went from $76 to $72, so he spent a total of $4, which is A. And this is one of these questions which it can be pretty easy to make a silly mistake. So once you do get this answer, it's a good habit to go ahead and plug it back in and see if it does make sense. So I'm pretty much going to do the reverse and assume that $4 is going to be correct. What happens if I substitute it back in? Well, $76, he spends $4, so we have 72. He gives half of what he has left to Charlie, so Charlie gets 36, and then Charlie spent a quarter of what Alex gave him on lunch. So a quarter of this is going to be $9, and yeah, it does work out. So we know that the answer is going to be A. Right. And now that we're at this sort of 10 question mark, we can sort of have a look at our time. How much have we spent on the first 10 questions of the test? If you're at around 10 minutes into the exam, you're on a pretty good pace. If you find that you're like 15 minutes in, 14 minutes in, then that's a good indicator that you should speed up, right? So whenever you get to like question 10 or like question 16, 17, halfway through the exam, always have a watch on the clock, because like all of these questions, they're not necessarily going to be the same difficulty, but every question is worth the same mark, right? So we just want to be prioritizing the questions which we can solve first. So don't want to miss out on like potentially easy questions at the end if you do run out of time. All right, question 11. A rectangular prism is made from identical small cubes. Each small cube is solid and looks like this from the side. And then we have 3 different faces on this prism. And we want to find how many cubes is this prism made of. So looking at it pretty quickly, we can see, oh, it has a maybe length or height of 3, length or height of like 5, and then the other dimension is going to be 2, right? So this is 5 by 2, this is 3 by 2, and then we also have a 3 by 5. So we can guess that the dimensions of the prism will be 2 by 3 by 5, and then that's just going to be our answer, right? Multiply these 3 numbers together. All right, on to question 12. So Jennifer sells bunches of flowers and she wants to make a picture graph to show the data in the table. And then we have 24, 20, and 36 on Monday, Tuesday, and Wednesday. And it says that she wants to use pictures that are either whole flowers or half flowers. And in terms of what each flower can represent, it can be 4 bunches, 8 bunches, or 12 bunches. So we want to find which of these 3 keys can represent the data correctly. So let's go through each one. So if each of these flowers represents 4 bunches, then this is 24, right? We can have it be made up of 6 of these flowers. This 28 over here, we can sort of split it up if we want to do it into 7 bunches, and the 36 also divisible by 4. So we can use key X, right? But what about key Y? If it represents 8 bunches. So 24 is divisible by 8. 28 over here, well, 24 is divisible by 8, but then we can also do a plus 4, right? So that's pretty much 3 flowers and a half. So yeah, we can represent 28 using bunches of 8. But what about 36? Same thing, right? We can do it with 4.5 flowers. And so key Y is going to work. And finally, key Z representing 12 bunches. So Monday and Wednesday, they're both divisible by 12, so they work. But we can't really represent Tuesday in terms of 12 bunches because, yeah, we can have 2 bunches. But then now we need to represent 4 more, right? And 4 out of 12, that's not exactly going to be half. So we can only use key X or key Y only. So that answer will be B. Go to question 11. Right, so let's go ahead and move along to 13. So 3 numbers are chosen from 3, 5, 6, and 8. They are then added together. So we want to choose 3 out of these 4 numbers, and which of these statements is or are correct. So total cannot be a multiple of 8. So rather than just trying to guess and check different combinations to see if it's a multiple of 8, let's find every single combination, right? So one way we can do that is if we add all of these numbers together, 3 plus 5 plus 6 plus 8 is going to give us 22, right? But like obviously we're not adding all 4 numbers, we're only adding 3 numbers. So in terms of what totals we can get, how we can think of it is I'm pretty much adding all 4 of the numbers except for one of them. And this number which I'm leaving out is going to give me the sum of the 3 numbers. So I can pretty much have 4 different possible sums, right? If I leave the 3 out, I'm going to get 19. So 5 plus 6 plus 8. If I leave the 5 out, I get 17. If I leave the 6 out, what do I get? 16. And if I leave the 8 out, so that's 3 plus 5 plus 6, I get 14, right? And these are going to be all my combinations. So the total cannot be a multiple of 8. Well, 16 is a multiple of 8. So statement 1 is just wrong. What about statement 2? The total can be a multiple of 3. So if we look through all of these options, none of them are going to be multiples of 3. So 2 is also wrong. And the total is always odd. We see the 16 over here is even, so 3 is wrong. So we have a case where none of these statements are correct. So yeah, this answer can be the case. All right, does anyone have any questions so far? All right, if not, we'll continue to move on. So diagram shows a triangle inside a rectangle. The area in gray is 84 centimeters squared. And what is the area of the triangle? So pretty much the area of the whole square minus the shaded area, right? So that will be 132. That's 11 times 12 minus 84. So that is going to give me my answer. And just from looking at this, if you start working it out, you see that, oh, my answer must end in an 8. And technically, we can just go circle D and move on because that's the only answer that ends in an 8. This is a trick that you can use for questions sometimes by just looking at the options and seeing what the number ends in. All right, so let's go move on to question 15. Right, looks like quite a long one. Seojung has been recording rainfall for the last 5 weeks by collecting water in a container. And the container was empty at the start of week 1. Seojung recorded the amount of rain in the container at the end of each week. And then we have these 5 different volumes over here, and during which 2 weeks was there exactly the same amount of rainfall. So the amount of rainfall would just be the difference between the amount of rainfall at the end of each week, right? So for week 1, we can see that there's sort of 3 of these blocks over here. Week 2, there's going to be 2 of these blocks. Over here, we can see there's 1, 2, 3, 4 of these blocks for the difference. Here it's 2, and over here it's some bigger number. But you can see we've already got an answer. It's going to be between the end of week 1 and the end of week 2, and the end of week 3 and the end of week 4. So what that pretty much means is it will be week 2 and week 4, right? After the end of week 1, that's week 2 starting. And then after the end of week 3, that's week 4 starting. So it'll be week 2 and week 4, which is D. All right, question 16. Brody is thinking of a quadrilateral. So there are no parallel sides, but 2 sides are 5 centimeters, 2 sides are 8 centimeters. So immediately we sort of know it has to be a kite, right? If they were opposite sides, it's going to be a parallelogram, but we don't really have any parallel sides. So we have this shape over here. and saying there's also one right angle that doesn't really matter too much for this question. So how many lines of symmetry does this quadrilateral have? So kite is going to have one line of symmetry, usually. All right, question 17. Gardener has a box of bulbs to plant in a garden, and the garden has 3 sections. She plants half of the bulbs in the first section, 3/4 of the remaining bulbs in the second section, and then she has 6 bulbs left, which she plants in the third section. We want to find how many bulbs were in the box at the start. So rather than dealing with random fraction calculations and all of that, I'll go ahead and draw a diagram, right? I'll just draw a big rectangle, and this will represent all of the bulbs. So half of it is in section 1, and then 3/4 of the remaining is in section 2. So let's go ahead and divide this into 4, and we have this part over here is going to be section 2. And what we know is that the 6 bulbs left is in the third section over here. So what does this mean? Well, we can see that there are like these 8 little sections in total. So we can get the answer by doing 6 times 8 is equal to 48. And that's going to give us E. But you can also just get, oh, well, section 2, or half of it is going to be 6 times 4, which is 24. So total is 48. Either way, you get the same answer. Right, so moving along. To question 18 next. So a cube has been painted around one vertex as shown. Which of the following diagrams could be a net for this cube? So we have to try and visualize each of these in our head. And before I do so, I want to go a little bit about how we can deal with these nets of cubes. So the thing with the net of a cube is that we can represent the same cube in many different ways in terms of its net, right? So if we look at diagram 1 over here, we sort of know that these corners are going to match up together. We also have this corner is going to link up with this corner, but we also have this corner will link up with this corner as well. So how can we tell that? Well, in our head, we can sort of just wrap this square around by this part over here to sort of see that happen. But one thing you can do is you can pretty much just rotate this square by just sort of rolling it around this floor over here, right? If we imagine this vertical line as a floor, what we can do is we can sort of have this cube side roll over once so that these two connect, and then we can have it roll over again. So this is sort of like, I'm not sure if you guys know the game Roblox, like we have a cube that's sort of rolling around. This is a similar thing. Like, let's say we have a bunch of these squares and we have this cube over here, right? Let's say there's an arrow pointing up. If I roll this once to the right, what's the arrow going to be facing? It's going to be facing right, right? If I keep rolling again, the arrow is going to be facing down. If I roll it again, it's going to be facing to the left, right? So why is this important? Because we can pretty much do the exact same thing with the net of a cube. So if we imagine this side over here, if we imagine it rolling it along this floor over here, if we roll it once, then this corner is going to link up with this corner over here, right? And this is already what we don't want, because essentially what this question is asking is which of these have all 3 of these corners in the same place. But diagram 3 over here already has it so that these corners don't really face the same vertex. So diagram 3 is not going to work. And if we look at diagram 2 over here, we can just see that, oh, if we roll this side along here, well, this corner and this corner, they're going to be on opposite sides of the cube, right? So we already know that diagram 2 is also not going to work. So in terms of which of these we can represent the original shape, it is just going to be diagram 1. And this rolling over trick is something that you can use for any questions which have nets, right? So let's continue going to question 19. So a bag contains 3 discs. We have red, blue, and yellow. And there is an equal number of red discs as blue discs. So I'll just say there's 1 unit of red disc, 1 unit of blue discs. And there are twice as many blue discs as yellow discs. So how can I represent this? There's like a 2-to-1 ratio. So I'll say there's 1 unit of yellow and 2 units of blue, which means we need 2 units of red, right? And we have all the information is going to be true. So if we select one disc without looking, what's the probability it's a blue disc? So blue represents 2 units. There's a total of 5 units in total, so that's just going to be 2 out of 5, right? So there are other ways to represent this information, but I feel that this is going to be pretty straightforward. Right, question 20. Right, here is part of a menu from a cafe. The prices have been torn off. So a burger and a drink cost $6 in total. And then we have chips plus a drink is $3.75 in total. And then we have a burger, chips, and a drink is $8.50 in total. And we want to find out how much a burger and chips cost. So if we look at these 3 equations, the difference between equation 1 and equation 3, well, equation 3 has all 3, but then equation 1 only has a burger and a drink. So we find what's missing. It's just the chips, right? The chips are missing. And these chips are equal to the difference in this amount of money, which is $2.50. And we do the same thing with the second and third equation. So in the second equation, the burger is missing. So the burger is the difference between the prices of the second and third, $3.75 and $8.50. That's $4.75. So how much is the burger and chips? If we add these two amounts, we get $7.25. Right, moving along. Question 21. So Jason's clock was working normally until 7:05 a.m. At 7:05 a.m. he dropped the clock, and for the rest of the day, his clock hands turned twice as fast as normal. I feel like it would make more sense if it turned half as slow, but it is now 3:25 p.m. that day, and what time did the clock show? So from 7:05 a.m. to 3:25 p.m., how much real time has passed, right? So what's the difference between 7:05 a.m. and 3:25 p.m.? So what we can do to make the calculation a little bit easier for us is we can convert it to a 24-hour time and say, oh, this is just 15:25, right? And then what's the difference between 15:25 and 7:05? Will be 8 hours and 20 minutes, right? So a total of 8 hours, 20 minutes has passed, but for the clock, since it's going twice as fast, we want another 8 hours and 20 minutes to be added. And then that's exactly what the clock is going to show. So if we add another 8 hours and 20 minutes, we have 11:45 p.m. So which of these clocks is going to show 11:45 p.m.? Looks like it's going to be E. Right, on to question 22. I have an equal number of $1 and $2 coins, and the total value of my coins is $54. It's an equal number of both. $1 coins weigh 9 grams, $2 coins weigh 7 grams. What is the total weight of my coins? So if we have an equal number of $1 and $2 coins, and the total value is $54, how many of each coin do we have? How we can think of this problem is we can sort of group them up into pairs, right? So I'll say in one pair or one package, there's going to be a $1 coin and there's going to be a $2 coin. Another package, there's going to be a $1 coin and then a $2 coin. So this is good because if I sort of divide into these little pairs over here, I'm guaranteed that there's an equal number of both, right? So if I sort of continue this diagram, it now becomes a question of asking, oh, how many of these little pairs do we have? So all of this is going to be equal to $54, and the value of each of these pairs is $3, all right? So now I'm sort of saying, how many of these are there going to be? How many of these sets? Yeah, 15 divided by 3, which is, 54 divided by 3, which is 18, right? So there's a total of 18 of these sets. And now I want to find the weight of all the coins. A dollar coin weighs 9 grams, $2 coin weighs 7 grams. So each of these little sets weighs 16 grams. And then my answer just becomes, what is 18 times 16? So from looking at the answers, without working through this calculation, which one is it going to be, A, B, C, or D? And like, how can we get the answer very quickly from this? So if you do the calculation, you can get exactly one of these answers, but I know that 8 times 6, it ends with an 8. And only one of these options ends with an 8. So this is how I can, it must be B. But if you just do the question, do this calculation, you get 288 anyways. But yeah. Right, 23. So two statues are 8 kilometers and 23 meters apart, and a map incorrectly labels the distance between the statues on a map. The incorrect distance is 23 kilograms and 8 meters. And what is this difference over here? So the question is very simply asking the difference. Shouldn't be too hard. So let's just convert everything into meters, right? This question is mainly just testing your ability to do these conversions. So we have a total of 23,008 meters. But the statues are 8,023 meters apart. So what is this difference over here in terms of meters? We have 5, 8, 9, 4, and 1. So from looking at the answers, looks like it's going to be 14 kilometers, 985 meters, which is B. Right, question 24. So we have this island, which consists of hills, bush, or both. And these three areas cover everything. So the total area is 164 kilometers. The hills are 132. And the area of the bush is 80 kilometers. And we want to find what area of the island has both the hills and the bush. This one will be pretty straightforward. We do 132 plus 80 is equal to 212. And if we subtract 164, we get 48. That's the answer. So why is this the case? Why can we add these two numbers up and subtract it? So if we think about what this island is made of, we have the bush-only region. We have the sort of bush and hill area region, and then we have the hill-only region, right? So let's say this is composed of these three different parts. So the total island has one of each of these, but if we go ahead and consider what the hills and the bush are for this, well, the hills will be one of the regions plus the other, and then the bush is going to be the very middle region plus the bush only region, right? And so if we add both of these up, we can see that there's a little bit of an overlap in this very middle region over here. So if we add them up, that's 132 plus 80. And if we find the difference between these two, that's just going to represent this overlap over here, right? We have one extra region for the hills and the bush. So that difference is just 48 corresponding to this part over here, right? So on to 25. A display has 3 lights that flash at different intervals. Red light flashes every 2 minutes, green light every 3 minutes, blue light every 5 minutes, and all lights flash together at 7 a.m. So how many times between 7:01 a.m., all right, we don't want to include that. And 9:59 a.m., we don't want to include 10 a.m. Do the green and blue lights flash together without the red light also flashing? So normally a question like this would be like, oh, how many times do all of them flash together? But in this case over here, we have two of them want to flash together, but then the red one, we sort of want to leave that out of the equation. So in terms of the green and the blue light, right? How often they flash together will be the lowest common multiple of 3 and 5, which is going to be every 15 minutes, right? But the red light is flashing every 2 minutes. So in terms of when we want the lights to be flashing together without the red light flashing, we pretty much want the time to be an odd number, right? So red light flashes every 2 minutes. That's like 2 minutes, 4 minutes, 6 minutes, 8 minutes. That's pretty much all the even numbers. So if I go ahead and list out all of the times, we have 7:15. Well, we don't want 7:30, so we have 7:45 next, then 8:15, 8:45, 9:15, and then 9:45. And that's going to be 6 different times, which is A. So I've decided to list out all of the times just because it's going to be pretty short, right? We're only going across 3 hours, and I can see very clearly, oh, it must be only 6 hours. I mean, 6 different times. If this was a longer period from like 7 a.m. to like 7 p.m., that way you can sort of generalize it, say, oh, it flashes twice every hour. And if there are like 7 hours, it'll be 14 times, right? And you generalize the problem that way. Right, question 26. So 3 planks of wood have the same length and they are placed next to each other as shown. What is the length of one plank of wood? So we have a bunch of overlap over here. It's 135 centimeters, including the overlap. And we're given this 40 centimeter and 5 centimeters together. So I need to try and think of a way to find what the length of one piece of wood is going to be, right? So if we think about what this 40 centimeters is representing, it's going to be this block over here, right, in green. Now, what is the 5 centimeter representing? It's going to be this block over here. And then if we think about what the 135 centimeters now representing, we can see that, oh, it's going to be this blue region plus this blue region plus this blue region, right? How we can think of it is, what if there's going to be gravity for these blocks and these blue blocks sort of fall into place over here? This whole part is 135 centimeters. And then if we sort of stack the green part as well, this 40 centimeter part, and then we also have the 5 centimeter red part over here like that, that's going to be the length of all 3 pieces of wood, right? So this is a way you can visualize that, oh, this 135 plus 40 plus 5 centimeters is going to be the length of 3 full pieces of wood. So what does that sum equal to? 180, right? So if 180 is going to be 3 planks of wood, then each plank of wood would be 60 centimeters. So this is just a visualization to understand why we're adding the numbers and then dividing by 3 also. By question 27. Alison showed 3 small squares in a grid below, and she wants extra squares shaded to make a pattern with exactly 4 lines of symmetry. So if you think about how a symmetry can occur on a square, there are only going to be 4 different ways, right? We can have a vertical symmetry, horizontal symmetry, or the 2 diagonals. And we want symmetry to go for all of these 4 different directions, right? So let's just go ahead and fill it in. So if we want vertical symmetry, right, we need this to be shaded, and this to be shaded, and this to be shaded. If we want horizontal symmetry, we need these to be shaded. Now, we also want the diagonal symmetry as well, sort of like this. And how do we do that? We need the rest of these shaded, right? And that's going to be it, right? I have all 4 of the symmetries done already. So what is this answer going to be? 1, 2, 3, 4, 5, 6, 7, 8, 9. So it will be D. All right, on to question 28. Miranda sold drinks at a class barbecue. The drinks were orange or lemon, and she sold 33 drinks altogether. And we want to find which of these statements cannot be correct. She sold 10 more orange drinks than lemon drinks. So how do you know whether this is correct or not? Let's just try and work it out, right? Let's just try and plug some numbers in. So if she sells, let's say, 23 orange drinks, then she must have sold 10 lemon, right? She sold, that difference is going to be 13. If she sold 22, there'll be 11. And that difference is going to be 11. If she sold 21 orange drinks, then the number of lemon will be increasing by 1 again. So 12 will be 9. So it looks like there's no way we can ever have 10 more orange drinks than lemon drinks if they add up to 33. So we can see that statement 1 already is not going to be correct. And that's the answer. But let's go ahead and confirm that others aren't true. Also, so she sold twice as many orange drinks as lemon drinks. Yep, this is possible. We can have 22 and 11. Making sure we're finding which of these cannot be correct. And she sold 5 more lemon drinks than orange drinks. And if you go ahead and try checking some of those, what if we have like 27 and 6? That's going to be too big actually. So let's try maybe like 15 and 18. That difference is 3. We want the difference to be a little bit bigger, 19 and 14. This difference is going to be 5. So rather than guessing and checking these numbers, let's try and understand this a little bit more. Why 1 does not work, but 2 and 3 can work. So we have the number of orange drinks and lemon drinks. We would say these are going to be x and y. So we have x plus y is equal to 33. And now we're talking about the difference over here. So if we want my difference to be, the difference between x and y to be 10, and we sort of solve these two equations over here, what we're going to end up getting is that 2 times the number of orange drinks is going to be 43. So the number of orange drinks is going to be 21.5, which doesn't really make sense. So we sort of know that, oh, this number over here, the difference has to be an odd number, right? That's sort of why 3 works, but 1 doesn't, because that difference is odd. And in terms of 2, with a bit of guessing check, we know that 2 can be true. All right, on to 29. So this shape is a trapezium with 2 right angles. So Anna has a square piece of card with length 24 centimeters, and we want to find the greatest number of these trapeziums that Anna can cut out from this card. So what I'm going to do to this trapezium is I will split this up, or I'll sort of duplicate it, rotate one of the trapeziums, and have this shape over here, right? So this part is going to be 2, because this bit is 2. This part is going to be 6, and this part is going to be 3. And now what I have is going to be a 3 by 8 rectangle that's going to be made up of 2 trapeziums, right? So I'll rephrase the question and ask myself, how many of these rectangles can I fit in a 24 by 24 triangle? Right? If we think about this 8 and 24, well, 8 can fit 3 times along this, 24 and 3, it can fit 8 times along this, right? So something like this. I'm not sure if this is 8 or not, but in terms of the number of rectangles, it's going to be 8 times 3, right? We have 24 total rectangles, which we can fit into this square. But we're not really looking for rectangles, we're looking for trapeziums. And if there's 2 trapeziums per rectangle, it will be 48, right? So the answer is going to be D. All right, on to question 30. Jamal makes a number sequence. He chooses the first number in the sequence, then he follows the rules one after the other repeatedly. Subtract 10, add 10, subtract 10, add 10, and so on. And we have the 6th number is 8451. What is the first number? So we have number 1, 2, 3, 4, 5, and 6. And this 6th number over here is 8, 4, 5, 1. So the sequence is that we subtract 100 and then we add 10. Subtract 100 and then add 10. Subtract 100 and we get 8, 4, 5, 1. So in terms of what's happening from the first number going all the way to the last number over here, we're subtracting 100 3 times and then we're adding 10. So overall, the change from the first number to the last number is that we are subtracting 280. So the first number minus 280 gives me 8,451. What is this first number going to be? It's just going to be 280 more than this, right? So let's go ahead and calculate that. 8451 plus 280. 8731 will be my answer. Right, question 31. Robot dog is facing southeast. So that's going to be this direction over there. He makes 58 quarter turns clockwise and 93 quarter turns anti-clockwise. So what direction is the robot dog now facing? So obviously we're not going to be doing all 58 rotations, all 93 rotations. So there are a few ways that we can look at it. So every 4 rotations is a full spin, right? So all we're really concerned about is the final quarter turns that are being made. So I don't care if there are 5 quarter turns being made. I can simplify that to just 1 quarter turn being made. Does that make sense? So what I'll do first is I'll just go ahead and subtract these numbers together because they sort of cancel each other out. 1 quarter turn clockwise, 1 quarter turn anti-clockwise. They result in no change at all. So this will be 5, and then 8 minus 5 is 3. So essentially we have 35 quarter turns anti-clockwise. Anti-clockwise like so. And if I go ahead and find the remainder after dividing it by 4, we have 3 turns anti-clockwise, right? And 3 turns anti-clockwise, I can rewrite as 1 turn clockwise. So there are a bunch of different approaches to this question, but if we turn this 1 quarter clockwise, we're going to be facing southwest, sorry, which is going to be E. So you can find the remainder when dividing by 4 and 58, and then 93, and then do it that way. But the important thing is that every 4 turns, it's going to be something changing. Right, on to 32. This shape is made from rectangles, and we want to find the perimeter of this shape. So what I'll do is I will not go ahead and add every single side. We do not need to do that. So we're sort of going to be using that staircase pattern for a rectangle where rather than adding all of these little sides individually, I'll sort of pop them outwards to form this outer rectangle, right? So this moves out, this moves up, this moves down, this moves to the left, and then I'll have this side move over here. So what I pretty much have is one greater rectangle, plus I have 2 more sides, which I haven't added. This 3 over here and this 3 over there. So my greater rectangle is going to have dimensions 16 by 15 because 14 plus 1 over here, right? So what's the perimeter of this? 31 times 2, which is 62, right? And then I still need to add these extra sides because I wasn't really able to pop them out to form that outer rectangle. So adding that extra 6, I should get 58. It looks like the answer is going to be E. Right, question 33. Timothy writes down the number 24. He reserves the digits to make the number. He reverses the digits to make the number 42, and then we have that difference is going to be 24. I mean that difference is going to be 18. And now what we want is we want to find a number which, when we reverse it, that difference is going to be 72 now, right? So I have a number AB, and if I reverse it and it becomes BA, I want this difference to be 72. So what is this last digit B over here, right? It's pretty much what I'm getting asked. Now, we sort of have a look at this. We can see that, oh, this is quite a big difference, right? If this is only a 2-digit number, we have B and A are going to be pretty far apart. So I might be able to guess that, yeah, maybe B is going to be like 9 or 8. If B is 8, A is going to be 1, but then we can't really have like 81 and 18. That difference is too small. If we have 9 and 1, 1 and 9, you will see that this difference is going to end up being 72. And the answer is going to be E, which is 9. Right? So this question, you can solve it using a little bit of algebra, where maybe what you could do is represent BA as 10B plus A. This AB can be represented as 10A plus B. If you find the difference between these, we pretty much have 9B minus 9A is equal to 72. The difference between B and A must be equal to 8. And so if the difference in my two different digits is 8, then pretty much 91 is my only possible answer. I can't really have like 8 and 0. It doesn't really work out. Because the numbers are between 10 and 99. Right, so let's go through the last two questions pretty quickly. So Harry has a large solid cube made from 64 small cubes, and he removes some small cubes and now sees this view on any side he looks at the cube. So a couple of ways you can do this question. You can pretty much just start with the whole cube and then subtract what is not going to be shown. But what I'm going to do is I'll do this question a little bit differently. So if we think about the final shape which we have, this final skeleton of the cube, it's going to be made up of these corner cubes, and it's also going to be made up of these edge cubes, right? And nothing else, only corner cubes and edge cubes. So how many corner cubes are there going to be? 8, right? How many of the edge cubes are there going to be? Well, there's 2 of these cubes per edge, but how many edges are in total? 12, right? So there's a total of 24 of these edge pieces and 8 corner pieces. So if we add them up, we actually get 32, which is our answer. And question 35, Aaron and Tom have a game where they each spin the spinner once, and whoever spins the highest number wins. They play this game 8 times. So during the game, Aaron spins 2 1s, 3 2s, and 3 3s. Tom spins 2 1s, 5 2s, and 1 3, and there are no draws. How many games does Aaron win? So this is probably one of the harder questions of the exam. It's sort of hard to think about how we can match these numbers up and allocate the numbers one to the other. And it's very easy to try and guess that it's going to be E, but E is not going to be the correct answer. And let's try and go through why. So we have Aaron's spins and we have Tom's spins, right? Aaron has 2 1s, 3 2s, and 3 3s. Tom has 2 1s, 5 2s, and 1 3. So if there are no draws, right, what that essentially means is if Aaron scores 1, then that means Tom either scored 2 or 3. If Aaron scores 2, it means Tom spun 1 or 3, right? And if Aaron spun 3, then Tom spun a 1 or a 2. So what I'll do is I'll go ahead and rephrase the question and like sort of ask you guys, oh, how many ways, or how can I sort of allocate these numbers so that a 2 is matched up with a 1 or a 3, 1 is matched up with 2 or 3, and so on. And the answer is going to lie in these 5 2s over here. But you can see at the very bottom, these 2s cannot be matched with these 2s over here. So pretty much we have to sort of do something like this, right? Where if Tom scores a 2, then Aaron must have scored a 1 or a 3. And there's a perfect 1-to-1 mapping over here. If Tom scores a 1, then the only thing that's remaining are the 2s. And that's sort of how the game plays out, right? So let's go ahead and count how many of these Aaron wins. That's the final thing. So he loses this one because they match with a 2. He wins this and wins this, but loses this, and then he wins these ones. Right? Because 3 beats 2. So if we count the total number of wins, it's actually going to end up being 5, and that will be the answer. And that's one way you can think about how to do this question. So we are around halfway through the lesson. So what I'll do is I'll give you guys a 5-ish minute break, and I want you to be back by 3:40. But during this time, if you have any questions you want to ask, you can feel free to do so if there's anything you missed, right? Otherwise, you can use this time to get a drink of water, go to the bathroom, or do whatever. And also, if there's questions you want me to do in the other booklet in particular, you can go ahead and message them to me, because we won't be able to go through every single one of them. If you ever get confused by any of these questions in the future, this recording will be out there somewhere.